Hello, my name is Marsha from Fundo, and in this video we are going to be studying matrices. The objectives are to study addition or subtraction of matrices, scalar multiplication of a matrix, matrix multiplication, finding inverse of a matrix, and finding the determinant of a matrix. Okay, a matrix is a rectangular arrangement of numbers into rows and columns. You can use a matrix to store information, e.g., population data, infant mortality rate. The dimensions or order of a matrix can tell us its size, that is the number of rows m and the number of columns n. So an example is this matrix. The columns are the ones which are going down and the rows are the ones which are going across from left to right. And the dimension of this matrix is 2 by 4, or we can say the order of this matrix is 2 by 4. Addition of matrix. Suppose if matrix A and matrix B and want to find A plus B. We can find the sum by simply adding the corresponding entries in matrix A and B as shown. A plus B, this is matrix A and this is matrix B. We say 4 plus 1, 8 plus 0, 3 plus 5, 7 plus 2 as shown below, and our final answer will be 5, 8, 8, 9. That is how we add matrices. Okay, we should also note that we cannot add or subtract matrices of different sizes. For example, if our A will be 1 by 2 and B is still 2 by 2, we cannot add these matrices or subtract these matrices because they have different sizes or different orders. When we are subtracting matrices, we simply subtract the corresponding entries. For example, we have matrix C and matrix D. To subtract D from C, that is C minus D, we say 2 minus 5, 8 minus 6, 0 minus 11, 9 minus 3. As this process shown below, and our final answer will be negative 3, 2, negative 11, 6. That is how we subtract matrices. Scalar multiplication of a matrix. Scalar multiplication of a matrix is when you multiply a matrix by a single number. So in this case of this matrix, and this our scalar is 2, that is our single number. So we say 2 by 4, 2 by 1, 2 by 0, 2 by negative 9. So to get this answer 8, 2, 0, negative 18. So in this case, our 2 is a scalar, so that's why it's called a scalar multiplication. We can also multiply a matrix by another matrix, that is matrix multiplication. In this case, we have matrix A and matrix B, want to get AB. So A is order 3 by 2 and B is order 2 by 4. So to see or to check if you can proceed to multiply these two matrices, the inner numbers, that is 2 here and 2 here, should be the same. If it was 2 and here there's 3, we cannot proceed to multiply. So since 2 and 2 are equal, we can proceed to multiply. And also, these numbers 3 and 4 here can tell us the dimension of the resultant matrix. That is the result, the order of AB. The order of AB will be 3 by 4. Or we can say it as, if you are to multiply a P by Q matrix with Q by R matrix, we'll get a P by R matrix. And you first check that the inner numbers, that is Q here and Q here, are the same to see if we can proceed to multiply. If they are different, we cannot multiply these matrices. Another example is shown here to our right. That is, we have 2 by 3 matrix and 4 by 2 matrix. So we cannot multiply these matrices because here there's 3 and here there's 4. So these numbers are different. So we cannot proceed to multiply. But if it was 3 here and 3 here, we could have multiplied these matrices. Also here, we have a 2 by 2 matrix, a 2 by 1 matrix. So since there's 2 here, there's 2 here, we can multiply these matrices to get a 2 by 1 matrix. Okay, our example of multiplying 2 matrices, we have A, B here, we have A, we have B, when you want to multiply to get AB. So the solution is AB, and we get AB by multiplying the row of the first matrix by each column of the second matrix. That is, say, negative 5 by 1 here, plus 3 by 2. That will be the first entry of the resultant matrix of AB. And the second entry in first row will be negative 5 multiplied by negative 1 by negative 1 plus 3 by 6. This will be the second entry of the first row, and the first entry of the second row will be negative 4 by 1 plus negative 1 by 2, negative 1, negative 4 by negative 1 plus negative 1 by 6. So it's like row by column. And we get our final answer will be 1, 23, negative 6, 2. That is how we multiply a matrix. Each row in first matrix will multiply each column in second matrix. Also should note that when you're multiplying matrix, AB is not equal to BA. So you can pause the video and try to find BA. You see it's different from AB. And also if you have A squared, it means we're multiplying the matrix twice. So we say A by A. So we're multiplying matrix A and another in the same matrix again, same with B squared. So we'll see you in the next video.